Alright, welcome back. This is chapter 11 on our star, the sun. So our goals for this chapter are: why does the sun shine? And what is the sun's structure? So why does the sun shine? Is it on fire? No. It would only last 10,000 years if that was the case. Is it contracting? No. And then it would only last 25 million years. It is powered actually by nuclear energy, and this will allow it to last 10 billion years. And right now we're about halfway through its life cycle. So what's causing all this is a balance, the gravitational equilibrium. Gravity pulling in balances the pressure pushing out. The energy balance is thermal energy released by the fusion in the core balances radiative energy lost from the surface of the sun. So gravitational contraction provided energy that has heated the core as the sun was forming, and the contraction stopped when fusion started, replacing the energy radiated back out into space. So what is the sun's structure? Well, it's about 109 times the size of the Earth. It has a mass of 300,000 Earths, and it is very luminous. So we have the solar wind, which is a flow of charged particles from the surface of the sun. The corona, the outer layer, is about 1 million degrees Kelvin. The chromosphere is the middle layer of the solar atmosphere. The photosphere is the visible surface of the sun with a temperature of about 6,000 Kelvin, or about 11,000 degrees Fahrenheit. Inside the sun we have the convection zone. This is where energy is transported upward by rising hot gas. And the radiative zone is energy transported upwards by photons. And then in the middle is the core, energy generated by nuclear fusion, 15 million Kelvin. So we learned that the chemical and gravitational energy sources could not explain how the sun could sustain its luminosity for more than about 25 million years. The sun actually shines steadily because nuclear fusion in the core maintains both gravitational equilibrium between the pressure and the gravity, and the energy balance between thermal energy released in the core and radiative energy lost from the sun's surface. The sun's structure from the inside out, the layers are the core, radiative zone, convection zone, photosphere, chromosphere, and the corona. Well, how do we know what is happening inside the sun? There are actually 5 mathematical equations, differential equations, that go into this. So we can make mathematical models, we can observe solar vibrations, and observe something called the solar neutrino. So patterns of vibration on the surface tell us about what the sun is like on the inside. And the sun vibrates about every 5 minutes. What causes solar activity? Solar activity is like weather on Earth, and this includes sunspots, solar flares, and prominences. And all of these are related to magnetic fields. So here are sunspots. They are cooler than the other parts of the sun's surface, about 4,000 Kelvin. The rest of the sun's surface is about 6,000 Kelvin, and are regions with strong magnetic fields. And if we take an instrument called a spectrograph and look at the magnetic field and the spectra of these sunspots, we can measure a splitting of these spectral lines. And we'll get into spectral lines later on when we get into looking at stars next week. But the splitting you see right here is called the Zeeman effect. Loops of bright gas often connect the sunspot pairs, and magnetic activity causes solar flares that send bursts of X-rays and charged particles into space. Magnetic activity also causes the solar prominences you see here, and they erupt high above the sun's surface. The corona appears bright in X-ray photos in places where magnetic field traps hot gas. And the coronal mass ejections send bursts of energetic charged particles out through the solar system. These charged particles then stream from the sun, can be disrupted, and disrupt the electrical power grids and disable communication satellites. And you see them spinning into the northern and southern lights. How does solar activity vary with time? It varies on an 11-year cycle. The number of sunspots rises and falls on an 11-year cycle. The sunspot cycle has something to do with the winding and twisting of the sun's magnetic fields, and this is a phenomenon that is not fully understood yet. So we have learned that the stretching and twisting of magnetic field lines near the sun's surface causes solar activity, and bursts of charged particles from the sun can disrupt communications, satellites, and electrical power generation. The activity rises and falls in 11-year cycles.